Now it's time for Mr. Belward to give a speech. Just search for that. That's the one. Hello, Alan. Nice to have you back here in Sweden.
It's a delight to be back.
Actually, Anna was one of the first persons that I met when I joined the spaceport 50 years from now. It was a pleasure meeting you then, and it's a pleasure now. You were active at the Space Application Institute at that time. I don't think it exists any longer.
No.
But you still work for JRC, the Commission Joint Research Center at ISPRA. Right? So you will tell us about the global aspects of the Copernicus program, not to be forgotten. You know, before it was named GMS, the Global Monitoring System, and you're an expert on the global aspects of that, so please.
Thank you very much. Good morning, everybody. Yes, I'm going to come at the global land surface from a slightly different perspective. I thought it would anchor it, in fact, very much anticipating the question on the SDGs, looking at it from the application side, and looking at how space is involved in monitoring the global pressure points. So the starting point, and as our very first speaker said, with the refugee crisis at the moment, the world is getting very much smaller, not physically, of course, but metaphysically, in terms of communication, in terms of globalization of industry, in terms of transport, and in terms of issues like climate change, which affect everybody. And perhaps one of the biggest things affecting us is population growth. And I think it's sobering to think that since 1950, the average population growth has been 127 extra people a minute. So for every minute that we're sitting in the room, there's 127 extra people on the planet. That's another 50 there. Now, it's not just that there's more of us, we're actually getting greedier as well. We're consuming more energy per person. We're consuming more natural resources per person. We are consuming more food per person, especially as we move that poor bulk out of poverty. The first thing you do when you get more money is you spend it on better food. Globally speaking, we're consuming more meat than ever before. If you look in China, for example, consuming pork used to be an annual event, and it's becoming more like a weekly event for many, many people. Now it takes 4 or 5 times as much land to create the same number of calories from a meat diet as a plant diet. So the pressure on the planet from those number of people growing is increasing. Now in fact those globes are to scale, and in 1950 there was 4.4 hectares of land per person. Now there is less than 1.6, and by 2050 there'll be 1.2. And don't forget that that's not where it's going to stop. The population of the globe, the 2015 prospects reckon that the population will not flatten out until we get to 11.1 billion people by 2100. When you look at the global risks that are affecting us, and the Copernicus services that Mauro just outlined are all about meeting societal needs. If you look at the World Economic Forum conclusions from this year, the Davos group, the 3 of the top 10 risks are actually environmental. The number 1 risk of all is water crisis. That's the biggest threat affecting the global social, political and economic security of the world. Then you have failure to tackle climate change, you have biodiversity loss and ecosystem collapse, all up there in the top 10. That's the first time that's happened. Until now, the World Economic Forum has been emphasizing banking crises, financial issues, migration. But now we're faced with a situation where 3 of them are environmental. If we're going to build policy that tackles those sort of issues, then they're best if they're evidence-based. Quick, brief history of Earth observation in Europe, I think, is worthwhile. Mauro said that in his last slide, one of the issues of Copernicus is to be at the forefront of technology. Europe's been there before, and it'll stay there again, I think. In 1858, already, just a few years after the camera was launched, people were getting above it to get that all-important view from above. Balloons are capricious, so we went to unmanned aerial vehicles, the drones of the past. This was the Bavarian Pigeon Corps of 1903 with a little camera strapped to its chest, and it would take photographs as it flew home. Now you don't have cloud issues, but you do have wingtip issues. You can see missing data there with the tips of the poor pigeon's wings. So there are issues, not fallible. It didn't last very long, because in 1903 was also the Wright brothers took to the air with aeroplanes. So unmanned aerial vehicles went on hold for 100 or odd years until recent history. Space is where it all changed, as Mauro said. That's the big issue with Copernicus. In 1957 there was Sputnik alone, and now we have about 8,000 satellites up there. Now, actually you can't really see them, can you? Because the sun's shining. Should the sun be shining in Stockholm in October? There are 8,000 satellites up there, if you count them. They're not all Earth observing. The problem is, many of them still are up there. And I think that this is a fascinating photograph. This is the one European Space Agency satellite, I'm looking at Bianca here, the one that has re-entered. All the rest are still up there, including NBSat, which is 10 meters long, weighs 8 tons, traveling at 23,000 kilometers an hour with nobody at the controls. And it's still up there. So space is quite a scary place. There are so many, they are banging into each other, which is a little unfortunate. Oh, it does seem a pity to cut out the sun, though, doesn't it? And satellites are imaging satellites, which is not very useful, but quite fascinating to see. Another point that Mauro made in that last slide was about the power that being involved in the space business gives us in terms of international dimension, international argument. And this is very much the case when you come to global land issues. People live on the land, they feel responsible for it. So having your own independence of observation is a critical factor, and many nations think that. In fact, there are 34 different sovereign states around the world that have chosen to finance and launch their own satellites. Now that map is a little misleading, because Sweden is a spacefaring nation in many different ways, in funding historical instruments like the Vegetation instrument, right through to the new ones. Collectively, Europe is a big player. As Mauro said, we've got 36 land imaging polar orbiters that have been launched by Europe. We're a major player in that field. And we have the 2 Sentinels which are up there working and providing beautiful images. Sentinel-2A, which was launched on the 22nd of June, is a wonderful instrument, and this is the first image that was acquired by it, which by sheer chance happens to be of where I work. It was just luck, wasn't it, Bianca? It wasn't planned that way. The satellite came over, most of northern Europe was cloudy, and then the cloud broke over the Alps, and we got a cloud-free image of Lake Maggiore where we are. Now, what I wanted to show here is actually a more worrying issue, if you like. What that image is showing is the spread of urbanization from Milan in the south, and the bottom tile there is actually the Expo. That's the Expo site. Right through to the center tile, which is the JRC, it's where I work, and then the northern one is a national park. It's the Val Grande National Park. But what you see is blue everywhere, and that's urban expansion. And on the European scale, we are losing 1,000 square kilometers of good land every year to urban expansion, to land take. And that's a major and worrying factor when you think about all those people that are going to require food and nourishment. And you see that in this data set that we've created here. This is the travel time map. It's basically a map of how long it will take you to reach a city of 50,000 people or more. So it's not, strictly speaking, urbanization, but it's a surrogate for urbanization. And Europe, you're actually quite lucky looking at that. Sweden and Norway is relatively ungolden. The gold is where it's the most densely packed. In fact, Benelux is the most heavily urbanized part of Europe, and in fact the whole world right now. And as I say, that's partly a problem because of the land take. So that urban expansion is taking land away from food production. It's also taking people away from food production. And China, where we think of China as this big country with massive food problems, they're actually abandoning their own agricultural land because the people are moving away from the rural into the urban, and the landscape structure is such that you cannot mechanize it. Those beautiful terraced landscapes that we're all familiar with from the geographical programs, you cannot put mechanization in there. You need people to farm it, and the people are not staying there, they're moving into the city. So agricultural land is being abandoned. At the same time, you come into the city, you earn more money, you spend it on meat, which means more land again. So you've got less people growing the food, you've got less land to grow it on because you're abandoning it, you've got less land to grow it on because your cities are expanding. So it's a triple hit, if you like. That's a problem because most of the calories that we consume come from the land. 95%, globally speaking, of calories consumed come from the land, but unfortunately, not 95% of the land can provide calories. And in fact, if you strip out all the soils that are too dry, too saline, too acid, too wet, you're left with something less than 20% of the soils of the world that are capable of sustaining crop production, agriculture, on an intensive basis. And even they are at risk. The red areas there highlight the soils which are in trouble with a climate change scenario in either direction. If the climate gets hotter, those soils, they're heavy clay soils, they'll get too hard to work. If it gets wetter, they'll get too sticky and muddy to work. So it doesn't matter which way the climate changes, those soils are going to be in trouble. Now, how are we doing in this area? Is Stockholm one of my pressure points on the planet? This is the Stockholm region. Stockholm's in the bottom corner. It's here. And that's the airport up there. Airports are always a good place to look for change. This is in 1985, and if we step forward to 2015, we do indeed see quite a lot of growth around the airport. You see a new runway's gone in. There's the airport. I've highlighted another couple of areas where there's obvious big urbanization. But essentially, on the planetary scale, if you look at those two images side by side, there's not a huge amount of change going on in this part of the world. Take exactly the same area in another part of the world, Saudi Arabia, and that's from 1984, and this is from 2015. That's a much more dramatic change. Each one of those round circles is a center point irrigation field. Each field is about 50 hectares. Each field is consuming more than 2,000 cubic meters of water a day to grow crops. If you think a 25-meter swimming pool has about 300 cubic meters of water a day in it, each field of there, 2,500, that's a lot of water that's being used. Put it into perspective here, if you stuck it on top of Stockholm, you go all the way out to the coast. That's a big chunk of land that's changed. That also has an effect on the climate system because it affects the exchange of energy and gas and water between the surface of the land and the atmosphere. If you go back to that picture there, you can imagine that the brightness of the planet's surface has changed quite fundamentally because of the way in which the land cover has changed. So there's a feedback between the global land service and the sort of monitoring we're doing and the climate service that you'll hear about a little bit later on. Start to look at some real pressure points, and we look at Africa. Very much in people's minds at the moment with the longer term migration. I know the short term is more from the Levant area, and we'll come back to that. But I think that graph is worth a little reflection on. In 1950, the population of Africa was less than half that of Europe. And that's the whole continent of Africa. They didn't hit parity until 1998. And since about 2000, the population of Europe has increased by 10 or 11 million people, and the population of Africa has increased by 210 or 211 million people. And our population is now flatlined and is in fact decreasing. Africa has hit 1 million already, and there's the little box in the corner, which I added this morning from the 2015 population statistics from the UN office, is going to double again. And it's unstoppable. It doesn't matter whether the birth rate declines. There are so many young people of sort of birth age in Africa now that it's an unstoppable process. That population is going to double and will double again. So the pressure on the land resource is going to be vast. Again, those are to scale. In 1950, there were 13 hectares of land per person. By 2010, it had come down to 2.8, and by 2050, it's going to be 1.2. By 2100, it's going to be less than a hectare per person. So we'd better get the use of that land, absolutely right. So the sort of information that the Copernicus program is generating in terms of what the land cover is, how it's changing, where the water resources are, is going to become even more critical than it is today. And this is just one example. This is from the Albertine Rift, Democratic Republic of Congo and Uganda border area in Africa. Those two countries are amongst the 15 or so whose population will not double, it will increase 5 times over the next few years. So the pressure is going to be enormous. Now I've highlighted 3 towns there, and I've put in a little yellow squiggle to highlight some forest area. That's the situation in 1984. And then, more recently, you'll see the little pink towns expand. They grow rapidly. It has a very fast urbanization process in the continent. And you see all the forest inside the green squiggle disappears. And in fact, you can actually see a very well-defined line here. That is the border of the Virunga National Park, you know, where the gorillas and things are. Now, that's a good thing in that the park boundary is respected. And one of the things that the Global Land Service does is to work with our colleagues in DG Development Cooperation to look at the integrity of the boundaries of all the protected areas that the European Union funds in Africa. Are we spending money on projects which are just paper parks? They're there on paper to make the countries look good, but they don't do anything. With the Copernicus service, we're able to say, well, actually, yeah, there's an issue, there's huge pressure on the land in this area, but the park boundary is intact. That park is working. It's doing what it should do. And so the money that's being spent on it is being used very wisely. At the same time, there's another message in there, which is the pressure on the natural environment to feed and provide fuel to the people who are living in the region. You've got those towns expanding. 600 million people on the continent today, if they want to cook something or boil some water, have to set fire to a bit of wood. And that's why most of that woodland has gone. It's for fuel. It's not to create land for growing food, it's to actually as a source of fuel. And we see that sort of process repeated elsewhere in the world. This is moving to Latin America, to Manaus, in the middle of the Amazon forest. And again, we're talking about energy and energy production and food and the natural environment and that competition for land. Do you use the land as a carbon sink for the climate people? Do you keep the forest intact in terms of the energy, gas, water exchange with the atmosphere? Do you keep it as a protected area for biodiversity? Do you convert it to biofuels? Do you clear it and use it for food? Or in this case, do you use it for hydroelectric? This was in 1972, huge area of forest, all intact. By 1985, you can see roads have gone in. You can start to see fields being cleared for agricultural production in the region. By 1987, you start to see a pink area appear on the river. That's where the forest is being cleared to make way for a hydrological dam, for a hydropower, hydroelectric dam. By December of that year, the dam's closed and the hydroelectric plant starts to function. But the dam doesn't stop filling, and it carries on filling, and it carries on filling, and it carries on filling, because somebody got the basic topographic mapping a fraction wrong. And at the end, that one hydroelectric dam flooded more than 2,600 kilometers of forest. And climatically speaking, it's been a disaster because it's produced so much methane that it's offset any gains from the hydro in the first place. But that's another story. On the European scale, that lake would fill most of Wallonia in Brussels. I couldn't put Sweden in because you actually have bigger lakes here than that. But nowhere else in Europe has a lake as big as that one. But you do. So if we want to know where is the water in the world and where are the lakes, which is another thing that we're looking at now in the Global Land Service, do we know? And I say we because the first numbers up there came from our group, and I think we're all wrong. I think every one of us has got it wrong. We might have got it right for a moment when we published the paper originally. But the trouble is, water doesn't stay in one place. Like we saw, Balbina, that dam wasn't there in 1985. In 85, in fact in 1987, it was all forest. In 1989, it was a 2,500 square metre lake, a kilometre lake, bigger than anything else in most of Europe. So water changes all the time. Lakes dry up as well, dams are removed, rivers meander. So it's a very dynamic surface. And not knowing where it is a real problem. It's a real problem for the climate modelers because you have to know where the water is as part of the forcing process. It's part of methane and carbon evasion modelling in its own right. It's vastly important for us. Me, I'm going to drink some. Biodiversity, energy, the hydroelectric, everything. So it touches on so many aspects of our lives, and yet we don't know very much about where the planet's water is. You look at a map, you look at Google Maps, and you think, oh yes, we know where every river and every lake is, but you don't. So there were questions asked before about big data, and one of the issues that we're facing is the big data in terms of getting a handle on that water. And we started to use the Landsat archive. We used 2.8 million scenes of it. Oh, thank you. Another one. And that map at the bottom is the distribution of it. Now that's 1.28 terabytes of data. It's quite big data. It's one thing storing it, it's another thing processing it and analysing it. If you want to look at a comparison, I tried to think what would be a valid one, and the Complete Works of Shakespeare is a pretty big book, it's about 2,000 pages, and if you digitize it, it's about 3.5 mega or something like that if you buy it on a Kindle. And I reckon that you could actually give every child in the European Union 3 copies of the Complete Works of Shakespeare, and you'd have about the same amount of data as we've processed for this global water thing. So it is big data. What we've done with it is to produce this map, which is a 30-meter resolution map of global surface water occurrence. So that's basically telling you where there's, over 30 years, we've looked at the entire depth of the Landsat archive. And each individual image has been processed to say, is it water or not water? As simple as that. And then we put the whole lot together as a map. And this is part of the resulting map. It's a map of the Palm Islands in Dubai, where they put in artificial nets, flooded it all with sand and concrete, and produced 530 kilometers of new coastline. So what you see in dark blue is where it's always, always water. And where it's white, it's never water. And where it's purple, it's sometimes water. And it might be sometimes water. It might be water once every 5 years. Or it might be always sometimes water. Like the Okavango Delta, where it floods every year, but for 6 months. So that dynamic is captured in this data set. So we have areas like Stockholm, where it's always, always water. And then we move on to the same sort of area, in fact 4 times the size in West Africa, where you can see they don't have much always, always water in the Sahel. They've got a fraction of the water. We have the Italian lakes where I am. Stable water, it's always there. You move to Australia, those lakes are sometimes water, very ephemeral. Now, having that information is strategically important as well as important for issues to do with human health and vitality and biodiversity. And we had a quick look at what's going on in the Levant because of the issues that are facing us at the moment. And what we see is a great deal of change in the water surface water in that region of the world. Now you can see that there are various parts, particularly around Fallujah, which is the Razazza lake in Iraq, and Baghdad is right in the middle of that group of lakes in the bottom corner. These ones here, Baghdad is sitting here. And most of those lakes are not solid blue. The water occurrence has changed. Using the data set that we have, we can actually look at which direction that change has occurred in. So we get situations like the green dam here, that's come into being in the last 15 years because somebody's dammed a river and a new lake has formed. But much more has disappeared. And the surface water resource in this part of the world is under extreme pressure. If you look at the other side of the country, at the Iran-Afghanistan border, again, black is where the surface water has stayed for 30 years and has not changed. Red is where it's disappeared. Green is where it's come into being. One small lake has been created, but look at the vast areas that have been lost. So we're building up a picture of that change as part of the surface. So what we're finding is that really land and water resilience is being tested as never before. It is a crisis. It's something that people need to be aware of. And it has major impacts on us all immediately in terms of the water you can drink, in terms of energy, in terms of industry, in terms of life, basically. But, and this is where it gets a little bit positive and the SDGs come into being, we are the #1 official development assistance donor in the world, the European Union. We have ratified the Rio Conventions, the Climate Change Convention, the Biodiversity Convention, the Desertification Convention, which is meeting this week. One of the things the Desertification Convention is discussing is the Sustainable Development Goal on land degradation neutrality. And the indicators is something where I think the Copernicus service in the future will have to dedicate far more attention to building up those indicators. Because the SDGs, it's not just the developing world, it's also us as well that have to report on progress towards the SDGs. So I think that's going to be a big issue facing us. So, last slide, last point, I think, and this is where Copernicus really strikes, information is sometimes our best defense. Someone once said you can't manage what you can't measure. And to a great extent, I think, I believe in that statement. And Copernicus is helping us measure so many aspects of the natural world. It doesn't mean that that's the end of the story, and Copernicus is very much about getting that knowledge to flow to the right people at the right time. And it's not stationary. There has to be research into the next level of Copernicus. Mauro already alluded to the next generation of Copernicus satellites, and I know the European Space Agency is thinking about it. What do we build next? Because we're going to have to start doing it now. Education and communication, which we're doing in the room, a vital part of it. And don't try and do it alone. And again, something that Copernicus is very good at doing, putting the policymaker, the research community, the industry that are providing the service, putting it all together. And even the policies themselves shouldn't be taken in isolation. So the industrial development policy, the education policy, the space policy of the European Union all need to come together, and I think they're doing so. So I have a pretty positive outlook, but there are alarm bells ringing as far as land and water resources are concerned. So with that, I think I'll stop. Thank you, Garen.
Thank you, Alan. Very nice to listen to you. You are kind of Hans Rosling of Earth's observations, if you know what I mean. Yeah, very pedagogic. There's still time for questions if you have any. Micros will be circulated.
Thomas Klein from the Swedish Agency for Marine and Freshwater Management in Sweden here. Alan, thank you very much for a very inspiring and thought-provoking presentation. You mentioned the connection of Copernicus to the SDGs, and what can be done to strengthen this connection and to make sure that Copernicus provides even stronger support to deliver us on the SDGs in the future?
I think that's an extremely pertinent and very timely question. The goals are set, the indicators are almost set, and I think it's incumbent upon us to talk to our partners. In my case, it will be Directorate General for Development Cooperation for Environment, but I think within each member state as well, talking to your counterparts in the Environment Agency, in the Water Agency, to determine not all the indicators by any means, but there are some of them which will, I think Copernicus can make an absolutely crucial step forward in terms of things like the percentage of the planet's area that's protected. Okay, it's not us that will measure that, but you can monitor the effectiveness of it. Likewise with the water, when it comes to looking at connectivity between wetland ecosystems and things like that. So I think it's a time to be very proactive now and bring people in some of the policy area domains that are not familiar with this technology, make them just a little bit more aware that, of course, it's not going to answer all of the questions by any means, but it can answer some of them, I think, in a very reliable and globally uniform manner. So I think it's time for advocacy. Get out there and talk to the partners.
Anyone else?
Well, I'll repeat my question from before then. Do you have any paper where you actually very specifically link your data to the SDGs and indicators?
Almost. There's a very large Excel table drifting around the European Commission at the moment with a list of the 17 goals and 100 and something indicators, and next to it my group and various other groups in the JRC and in all the other DGs have scribbled in little notes of we can do this, we could do this. And so it's nearly there, but it's not something that we could actually hand out to you tomorrow, but maybe the day after tomorrow. Actually, not the day after tomorrow, give us a few weeks.